Hey, good morning. So, yesterday we went over the source-free RC circuit, which has a time constant to discharge. Today we're going to be doing something similar. We're going to be working with a RL circuit, which is a resistor and an inductor in parallel. So, instead of this capacitor over here, I'm going to press F5. We're going to cut this out, and we're going to place an inductor here. Oh, actually, let me see if I can make some more room for this symbol. Okay, L for inductor, and then F3 for wiring it up. And unlike resistors, capacitors, and inductors have a dot for directional uses. However, in this example, we don't really need the dot, so I just wanted to point that out. So in this example, we have an inductor of how many henries? We could see if there's an example in here that has an example of how many millihenries or henries this inductor is. So let's just say it's 1 Henry or 2 Henries. There's some examples in the book that are using 1 Henries or 2 Henries. Yeah, so I'm going to say it's going to be 2 Henries. L is 2H. VA is over here. And instead of this V.IC initial condition of V of VA equals 5, we're going to say this is going to be I of VA, because we need to I of L1 equals, and it should be with current. We're working with current, right? So the initial current in the inductor is going to be I don't know, what should we use? 500 milliamps? 10 milliamps? I'm checking the book for some examples. I of 0, let's just say it's 1 amp. 1 amp, okay. So then transient of 500 milliseconds. We're going to run through this example. We're going to run the program. And then let's see if we have a reasonable trace, or once we probe. I of L1, I of R1. Okay, it should be, hold on, it should be a similar e to the negative t over tau graph with a time constant. But we're not getting that, so hold on. Okay, so continuing where we left off, to find the time constant is going to be let's see. Tau is going to be L divided by R. Tau is going to be L divided by R. So 2 Henries divided by 10 kiloohms. Let's see if I can pull up a calculator over here. Calculator. So 2 divided by 10,000 is going to be 0.2 milliseconds. 0.2 milliseconds. So, and it's going to be about 5 tau, or let's see. After 5 tau, multiply this by 5 to see what we should simulate the time constant, the transient should be. So if our initial condition of L1 is 1 amp and our inductance is 2 henries and our resistance is 10K, according to this formula, it should be, we can simulate it. We're going to do 2 milliseconds for the transient, and then you can see here under the curve, it's very similar to the other curve for the IC, the RC, excuse me, the RC time constant. However, this one is inductance of the current rather than the voltage. So this is current. Remember, V equals IR. So then current is going to be voltage divided by the resistance. Voltage divided by the resistance for the current through this entire circuit. This LR circuit, excuse me.